Okay, so in this problem, we're going to be finding the magnitude of the net force that Q1 and Q2 exert on Q3. And then we will find what is the electric magnetic magnitude at the location of Q3. So first, we will write down the equation that we're going to use. So the equation that we're going to use is going to be F equals K, and then the absolute value of Q1 times Q3 over R squared. And this Q3 right here is the force that we are trying to find, or the force that's being exerted on. So we will plug in our variables. F is going to equal 9 times 10 to the 9 times 1 times, and remember, negative signs do not matter here because it's all going to be an absolute value. So we'll have 1 times 10 to the negative 6 times 2 times 10 to the negative 6 all over, and then our radius is going to be 4, so we have 4 squared. Now, when we plug that into our calculator, we get a value of 0.00113 rounding newtons. And then remember, this is going to be in the J direction, so we'll put a hat J. Actually, I'm just going to rewrite this down here. 0.00113 newtons, or in the J newtons. Okay, so now we'll do the equation for the other charge, which what we're going to do is simply replace our Q1 with Q2. So we'll plug in our variables. 9 times 10 to the 9 times 1 times 10 to the negative 6, practically the same equation, all over our radius, which is going to be 3 squared. So after we plug that into our calculator, we're going to get a value of 0.002, and it'll be in the I direction, newtons. So our force net is going to be 0.002 in the I direction plus 0.00113 in the J direction, newtons. So here's our final answer. Now, we'll move on to the next question. What is the electric field magnitude at the location of Q3? So this is very simple, and we'll use a very simple equation. F is going to be equal to Q naught, which is in this case going to be Q3, times E, the electric field. So we can rewrite this equation so that's in terms of E, which is very simple. We'll have F divided by Q naught equals E. So when plugging in our equation, we'll use the answer we found before, but we won't have it in this form. Let's find the magnitude of our force, and to do that, it's going to be 0.002 squared plus 0.00113 squared square root all that, and then we will plug that into our calculator. 0.002 squared plus 0.00113 squared, and we get a magnitude of 0.002 3 newtons. So we'll plug that into our equation, 0.0023 over 2 times 10 to the negative 6. We'll plug that in our calculator, 3 divided by 2 times 10 to the power of negative 6, and we get a value of 1150. Remember, the units is going to be volts per meter. And that is our final answer for part 2. Okay, so in the next part, we are going to find the maximum speed it'll reach when let go freely. So, in order to do this, we need to use the equation U equals K Q1 Q naught R1 plus Q2 Q naught over R2. And then you have the option to keep going depending on how many charges you have. So since we only have two charges that are applying a force on one charge, we only need two. And this right here is our potential energy, which we can replace with 1/2 mv squared. Okay, so now let's plug everything in for this and get an answer. So what we'll have is 9 times 10 to the negative 9, not negative, positive 9, times negative 1 times 10 to the negative 6, times 2 times 10 to the negative 6, all over a radius. What was our radius? Of 4. Okay, I'm going to move this over. And then we'll have, again, our 9 times 10 to the negative, or to the 9, times 1 times 10 to the negative 6, 2 times, still don't have enough room, 2 times 10 to the negative 6, all over a radius of 3. So, when we plug all of that in, we get an answer of 0.0015. So now we'll just add our energy formula over here so that we can find velocity. So, before we do anything, let's maneuver our equation around so that it's in terms of velocity. So in doing so, what we'll have 0.0015 times 2 divided by m, all square rooted, and that'll be our answer for v. So if we check up here, we are going to have a mass of 10 to the negative 10 power. So we can replace this 10 by 10 to the negative 10, negative 10, and now we just plug this into our calculator to get 0.0015 times 2 over 10 to the power of negative 10, and we get a velocity of 5,477.2 meters per second. And this will be our final answer for this part.